Today we're going to be solving systems with conics. Our objective is to be able to solve a system algebraically that includes conics. In example number 1, I see that I have a linear function and I also have a circle, okay, looking at the two forms. So there's lots of ways to solve this, but what I'm going to use is substitution because I know what y equals. So I'm going to take y and substitute it into my second equation, which is going to give me an x squared plus, in parentheses, I'm now going to do my substitution. Everything else stays the same, but my y now becomes a negative x minus 7. Now I'm going to combine like terms. I'm going to get x squared plus negative x. Okay, if I add those again, negative 3 quantity squared equal to 17. And now I'm going to have to distribute. Let me just kind of show you the work. Remember, squaring just means I'm taking negative x minus 3 and multiplying it by itself. Okay, so I'm going to get x squared plus a negative times a negative is positive, so x squared, negative times a negative is a positive 3x, plus 3x plus 9 equals 17. So now I'm going to combine like terms. I get 2x squared plus 6x, and if I subtract 12 over, subtract 17 over, I'm going to get a negative 8 equal to 0. Alright, I notice that 2 goes into each one, so I'm going to divide each term by 2, so I'm going to get x squared plus 3x minus 4 equal to 0. Okay. So I know this is a trinomial, so this is going to become an x plus 4 and an x minus 1. Okay, that gives me a negative 4 when I multiply and a positive 3 when I add. So if I solve, I get x equals negative 4 or x equals 1. So, but remember, I'm trying to find the points of intersection. So all this tells me is that in my final answer, I'm going to have a negative 4 comma something and a 1 comma something. So how do I find the y value? Well, if x equals negative 4, I know that y is equal to negative x, which is a negative 4, minus 7. Or y is equal to 4 minus 7, which is negative 3. So I get negative 4, negative 3. But what if x equals positive 1? What happens? Well, if x equals positive 1, I get y equals negative x minus 7. So that's y equals negative 1 minus 7, which gives me a negative 8. So what this tells me is that if I graph this line and this circle, they're going to intersect two places, one at negative 4, negative 3, and one at 1, negative 8. And you can check by substituting in a negative 4 and a negative 3 into each equation and making sure they're both true, and the same thing with plugging in a 1 and a negative 8 into both equations and showing that it's true. Our next example is a little bit trickier. Okay? Our first example is actually an ellipse, and our second one is a hyperbola. So where would this oval or ellipse intersect our hyperbola? Well, a couple ways to do this, but this one's set up more for elimination. So for this, what I'm going to do is try to eliminate either the x's or y's, and it doesn't matter which one. Now, for me, I'm going to eliminate the x's just to show you, since we solved for x first in the last one. So to do that, okay, I could say, for example, multiply the first one by, say, a 4, and the second one by a negative 3. If I do that, I'm going to get two new equations. My top equation is going to become 12x squared plus 8y squared equal, and if I multiply that out, I get 0, 2, 12, 140. If I multiply my second equation by a negative 3, I get negative 12x squared positive 9y squared equal to a negative 72. So now what I want to do is I want to add my two equations, and if I do it correctly, something should eliminate, hence the name elimination. So I'm going to get a 17y squared equal to a positive 68. So what I want to do next is divide both sides by 17. Okay, and if I do that, I should get a 4. Okay, and then take the square root of both sides. Now this is where most students make a mistake. If I take the square root of both sides, I should get a plus or minus 2. So what that tells me is that in my final answer, y is going to be a positive 2 or y is going to be a negative 2. But now I need to find the x. So how am I going to do that? Well, if y equals positive 2, I'm going to take either equation, it doesn't matter. I'm going to take the top equation. I know 3x squared plus 2 times 2 squared should equal 35. So 3x squared plus, okay, this is, you have to do order of operation, exponents first. So 2 squared is 4, 4 times 2 is 8, equals 35. 3x squared is equal to 27, x squared is equal to 9, and x is equal to, now you have to be careful, to plus or minus 3. So what this now tells me, if y is 2, I get not only a positive 3, but a negative 3. So I actually get 2 points here. So when y equals 2, we actually get an x of 3 or x of negative 3. So you could write it that way because this positive 2 goes with both of those x's. But what if y was negative 2? Let's see if it actually makes a difference. Well, when I substitute it into my second equation, okay, and again, all I'm going to do is plug it into the same equation. It doesn't matter which equation you substitute in, but now I'm just going to substitute in a negative 2. I'm going to see I'm actually going to get the same exact answer because negative 2 squared is 4, 4 times 2 is 8. And now all of this work ends up being exactly the same. Okay, so I know x is equal to plus or minus 3. So you can write your answer that way, or if you feel better writing them out separately, you get 3, 2, negative 3, 2, 3, negative 2, and negative 3, negative 2. So this one, if I have this ellipse and a hyperbola, they actually intersect at 4 different places. I hope you feel a little bit better about solving systems with conics using either substitution or elimination, and as problems get a little bit harder, you're going to see that you might have to use the quadratic formula to solve for x or y, or use a little bit more factoring techniques. But in any case, it's the same steps over and over again. Your goal is to either solve for x first or y. Once you find that value, substitute it back in to find your other points of intersections.